3.4 equivalent statement. We have equal statement if we had, for the last column, we had exactly same answers, meaning that they have same number of truths and false. The rightmost column of the truth table, that means the last column that we use for to find the final answer. We have converse, inverse, contrapositive. The first one, converse conditional statement, is P implies Q. And finding converse of this one is that we have to switch order of letters. So that's, instead of having P implies Q, we're gonna have Q implies P. So switch P and Q. For inverse, again, this is based on conditional statement, and that is P implies Q. With we want to write inverse of this conditional statement, we should use negation for each one of these. So add negation. We're not switching letters, but adding negation. This is inverse. Contrapositive of conditional statement, we have to switch letters and also add negation. So for this part, switch P and Q and add negation. This means we combined converse and inverse to have contrapositive. Next one, De Morgan's law. So the first one, negation of P and Q. The second part is negation of P or Q. When we have negation, that means this is not true. So it is false that. And we have to apply this negation to both of our simple statements. So applying that one, first we have negation P, then we have negation Q, but the point is you have to change from and to or. Do the same thing for this part. You have to change the symbol from or to and. If not, the answer is not equal to. We're not going to have equal to in between if not changing from or to and or from and to or. Construct a truth table for conditional statement. P implies Q. Its converse, inverse, and contrapositive are any equivalent statements. So we have to draw a table based on all these that are given. So the first one is conditional statement P implies Q. Yeah, for converse, we have to switch order. For inverse, we have to add negation. This one is negation P implies negation Q. And finally, contrapositive, combining converse and inverse. Here is negation Q implies negation P. So we have to construct truth table and then compare all these. So the third column is based on first one is negation P. So this is false, false, true, true. Then we have negation Q is based on second column. So we have false, true. false, true. Now the first column is conditional statement. So it's P implies Q. So we shouldn't have true implies false. This part we have true implies false in second row. That's the only one. Here we have true implies true is true. False implies true is true. And false implies false is true. The next one is Q implies P. So Q implies P, we have true implies true is true. False implies true, so you have to read this way. False implies true. True implies false. False implies false. Negation P implies negation Q. And finally, this one is for contrapositive. We have negation Q implies negation P. Now it's time to compare these four columns: conditional statement, converse, inverse, and contrapositive, and see if do we have equivalent statements? Do we have exactly same answers? For conditional statement, we have true, false, true, true, and that is exactly the same thing for contrapositive as true, false, true, true. So these two statements are exactly the same. So conditional statement and contrapositive. And also we have converse and inverse. Here on this part, we have to use De Morgan's law to determine whether the following statements are exactly the same. So in this part, we have negation of negation P or Q. We can use a truth table, or I can write this way. So I'm going to have both of these. I want to apply this negation here. Now we have negation of negation P. And we have negation of Q. The point is, when having negation, for both of these, applying this one to have De Morgan's law, we have to change what they have in between. In between here I have or, we have to change it to and. So negation and negation again, it's same as having negative times negative, so it's positive. We have P and negation Q. This is exactly what they have here. These are exactly the same. So our answer for this part is yes. Now I'm going to draw a truth table. true, true, false, false. Next one, we have true, false. Having negation, we only need to change from true to false, from false to true. So based on the first column, we have true negation. P is false, here false, true, true. Now based on the second column, we have false, true, false, true. We have negation P or Q. So it's second and third column, and between we have or. The rule was we should have at least one true to have true. Now again, here we have negation. Based on this column, it's true. So here we have false. False is true. And finally, comparing with what we have on right side, this column, P and negation Q. It's P. It's the first and fourth column. Between we have and. We should have two truths to have true. So the first one, true, false. We have true, true. The only one that is true is the second row. So here was asking to compare these two columns. Do we have exactly same answers? So here again, we have exactly same answers. We are going to use truth table on these. So here we have the third column is negation Q. So this is false, true, repeat. Now fourth column is P implies Q. So the second row we have true implies false. So this one is false. All others are true. Not true, false, not false, true. And finally, we have P and negation Q. So we have and in between, we should have true, true, to have true, if not false. So the only one that is true is this one, true, true is true. Now the two columns that we have to compare are these. Do we have equivalent statements? Have exactly the same thing. So that's why we have 3 letters. So we have 8 rows for true and false part. We have P implies Q. It's better to find the one that you have. Since we have to move, we have to start from left to right. We have to see if do we have true, false. This is true implies false, true implies false. So that one is false. So these two are false, but all these are true. Now, fifth column, Q plus R. So we're working based on the second and third column. And here is true. This one is false. So this is false. We have another one here. True implies false is false. We have P implies Q. This one implies R. So we have to move from right to left. It's not left to right. Finding true implies false. So now our arrow is this way. So these are false. All these true. So it's P implies Q implies R. So the first and fifth column. Okay, so that's the only one that we have. True implies false. This is false. Now, finally, we have to compare these two columns. Since we don't have exactly the same thing, we have true, false, true, true, true. But here, on this part, we have false, true. Same thing here. So these are not same. Okay, first, we have to see what is given on this part and write symbolic form. And then after that, use De Morgan's law, and again, translate. If Sally takes the new job, then she will not move, or she will buy a new house in town. Here we have if then statement. I'm going to use, for this part, Sally takes the new job, P, she will move. So first I'm going to write symbolic form. We have P. This is if then statement. Now the point is that here we have she will not move or she will buy a new house in town. I know that here is asking to use De Morgan's law, so I'm going to use that not here offside. This means she's not going to move and she's not going to buy a new house. If I want to change from or to and, so she will not move and she's not going to buy new house. Meaning that here inside, I should have Q or R. We're using De Morgan's law. Now we have P implies, I have to apply this negation here. It's negation Q, changing what they have in between from or to and. Negation R. So if Sally takes new job, she will not move and she will not buy new house in town. Now we have to translate what we had here on this part after using Newton's law. It is false that Challenger is a Chevy or Camaro is Dodge. So let's see what we have here. So it is false that, meaning that it is not true that the Challenger is Chevy or Camaro is Dodge. It's like that. This one is not true. So we have negation. I'm going to use P for this part. And here Q. We have negation of P or Q. Applying this negation using De Morgan's law, we have negation of P, changing or to and, negation Q. And we need to translate. So it's not Chevy. Between we have and. Here again is not. Use the fact that P implies Q is equivalent to negation P or Q to rewrite the following statement. Part A, if Ollie is not on radio, the visor is working. So first we have to write symbolic form for this part. Here we have not. We have if then. We have if then statement. First one is Ollie is not on radio. For this part, let's use negation P. And visor is working as Q. So this is what we have for what is given. Now the point is, here it's asking to write the equivalent statement using what is given on top. It says this is equivalent to negation P or Q. So we have to use the part that is given on top to be able to find the equivalent of part A. So I'm trying to find what we have here. So using what is on top, this one is equivalent to negation P or Q. Now I'm trying to have, instead of the first one, I'm trying to have negation P implies Q. So it's P implies Q, but instead we want to have negation P implies Q. You have to compare what's the difference. Here we have Q, same. This is implies same. We have P. The only part that is missing, the first part that was given is negation. So we added negation here on that part, meaning I should do same thing for the second compound statement. So this is equal to on this part we have exactly the same thing Q. Here we have exactly the same thing or here we should have P. This one simple statement was P. It had exactly the same thing on that part, but here we have negation P. So let's have that part. But I should add another negation at the beginning. So it's negation of negation P or Q. So here is the final answer. Negation P implies Q is equivalent to P or Q. Is everything else the same? Exactly same. See, all these are exactly same. The only difference is negation that comes first. And finally, apply this negation here, negation. We don't have negation. Same as having negative times negative is positive. So the answer is P or Q. We have to rewrite. After finding this P or Q, we have to translate. I'm going to translate that part. Ollie is on the radio. Or Caesar is working. So here is our answer. The Foo Fighters will practice or they will not sound good. So we have to write symbolic form first. For Foo Fighters practice, I'm going to use P or here we have not in between. So this one is negation Q. So here we have P or negation Q. We have to find the second equivalent statement. Again, we have to use what is given here on top. So P implies Q. This is exactly the same as negation P or Q. Now what we have here on this part is P or negation Q. If I try to compare the first statement with from what was given and also what we have here on this part after writing symbolic form, can see that on the first one we have if then statement, but second one we have or. But here again, here you have or in between, so it's better to compare this way. Because these, anyways, these are if one statement, it doesn't matter with which one we compare. So let's compare these, see what difference is. So what is given here on top, we have negation P or Q, but the one that we have in part B is P or negation Q. So we don't have the first one, we have negation for P, but for B we have negation is for Q instead. Okay, so what I'm going to do first, I'm going to write steps that I'm going to use. Here, the first one I will compare. This one that was given negation P or Q with P or negation Q. I noticed that here on the first one, I have negation. Here I don't have negation. But for the second part, here I don't have negation, but here is negation. Now, after finding that part, now I'm deciding to compare. Instead of negation P or Q, I'll compare Q or negation P. See what I did? I only changed the order. Instead of having negation P or Q, now I'm having Q or negation P. It's exactly the same. So compare the last one with P or negation Q. But my conclusion is I'll decide to switch P and Q. Why? Because here we have Q, but here is P. Here is negation P, but here is negation Q. So switch. P and Q. From, so we have to switch from, yeah, our given part was P implies Q. Now in this part we have Q implies P. So based on what we had in our conclusion and what we compared in step 2, we decided to switch Q and P instead of having P implies Q. Now we have Q implies P. So after writing symbolic form, we have to rewrite this compound statement. Again, here we have if then. Same as that, for here we have if then. So if they will sound good, then the Foo Fighters will practice. Okay, so here is our final answer for this part. Part A, if Sally goes to mall and she buys stuff she doesn't need. We have if then. I will use P here. And she buys stuff. This one is positive. We don't have not for that part. So I'm using Q for this statement. Meaning what I have here, the first, you know what conditional statement is. Is P implies Q. Now writing converse, inverse, contrapositive. So for converse, we have to switch order. Instead of having P implies Q, now we have Q implies P. You have to remember these. For converse, you have to switch P and Q. For inverse, add negation. For contrapositive, switch P and Q and also add negation. This is what we have for converse, is Q implies P. Inverse, adding negation, here again negation. Now contrapositive, switch and add negation. And now rewrite each one. So first we have Q. She goes to mall. Next one is inverse. Again, if then. We have, the first one is P, so adding not in the first part. She does not buy. You also have to see by reading if this one is logically correct. Is that reasonable to have this? So not going to mall, obviously she's not going to buy. Finally, control positive. We have negation Q. So if Sally does not buy, then she does not go to the mall. So reading all these are logically correct. Part B, if the water is running and Tom is getting drink, here again, if then, water is running P, Tom is getting drink Q. So here again, our conditional statement P implies Q. Now writing all these three, converse, inverse, control positive. So P implies Q. Now here we have to switch order. So first we have Q. If Tom getting a drink, then the first part, water is running. Inverse. We have to add negation, so it's negation P. If the water is not running, then Tom is not getting a drink. So that is correct. Now control positive, switch and add negation. The first one, if we have if Tom is not getting a drink, then the water is not running. Determine which, if any of the following statements are equivalent statements. Number one, if Bill is the director, then Peter is actor. The first, writing symbolic form. We have if then. Bill is director, this is P. Peter is actor, is Q. I'm using exactly the same thing for all these because we have same simple statements. Bill is director, P. Peter is actor. For that part, I will use Q. I'm writing symbolic form for the first one. P implies Q. Now, second statement, Bill is not director, so it's not negation P. Or Peter is not actor. So again, we have not. It's negation Q. The third one, here we have it is false that, or it is not true that. So we have negation of Bill is director, that is P, and Peter is not actor. So add negation Q. So these are what we have for number 1, 2, and 3. Now asking to see if do we have exactly same answers. I'm going to draw a truth table. We have P implies. Here we have or in between, negation P or negation Q. Here we have P and negation Q. Finally, here on the last column we have. Now we want to compare what I have here, here, and here. These 3 compound statements from number 1, 2, and 3. See if do we have equivalent statements. So here we have true, false, true, true. Here again we have true, false, true, true.